Welcome to the EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at database management system, and for today's lecture, I will be talking about database system architecture. The learning objectives for today's class would be on data models, categories of data models, classification of database management system, and schema architecture. To start with, initially we will look at data models. A data model is generally a set of concepts to describe the structure of a database, and this has more correlation towards the schema of building a database architecture system. So, a set of concepts to describe the structure of a database and certain constraints that the database should obey. There are a list of constraints towards integrity, accessibility. Those likewise few list of constraints are also been there. This particular data model has to obey all these constraints. Further, it has to come under a common platform of the structure so as to form a very good data model. Some of the operations of data model include operations for specifying database retrievals and updates by referring to the concepts of data model. Operations on the data model may include basic operations. Later on, we will be describing it as relational algebra operators and user defined operations. Some of the categories of data models include conceptual data model, physical data model, and implementation data model. If we refer to conceptual data model, these are supposed to be the high level semantic data model. By semantic, we mean the meaningful entities that are associated to this particular data model. This conceptual data model gives a complete provisions of concepts that are close to the way many users perceive data. So, how users look at every data will be at the conceptual model. Those are logically related. This is also called as entity based or object based data models. So, anything which is particular to the entity which the user views as such, those are called conceptual data model, and this is how it has been closely associated with the mini world. So, whatever people look at in the real world in terms of entity or as an object will be closely referred to as conceptual data model. The second category of data model is physical data model, where it provides concepts that describe details of how the data is getting stored in the computer. So, any specific concept that is being described in the relations of a relational database model, it describes on how these values are getting stored into the database. And the third one of the data model include implementation data model, which is representational in purpose. So, it provides the fall between the above two, that is the physical and the conceptual data models, balancing the user views with some computer storage details. How these are basically getting stored into the computer will also be taken care, and how the users will generally view it will be thought of. So, to divide the data models into three different categories, one would be called as object based data model, the other one would be on record based data model, and the third one is a physical data model. These object based and record based are towards implementation and conceptual model, whereas the physical model stores the values into the database. Object based data models include representations like entity relationship, meanings, that is the semantics of the information, functional and object orientation, whereas record based data model include relational data model, network data model, and hierarchical data model. To look at the history of data models, initially we will see what this relational model would mean. This relational model is proposed in 1970 by E.F. Cott. It was part of the development of IBM labs. This was made commercial in the year 81-82. Although it was initially perceived in the year 1970s, it took 10 years for it to completely develop and make it as a commercial version. Several commercial products like DB2, Oracle, SQL Server, Sybase, Informix were supplementary to this. Coming to network model, this is The first one to be implemented by Honeywell during the year 1964-65, and it is called Integrated Development System. Adopted heavily due to the support of CODASIL. Already I have told you about CODASIL. This CODASIL is an abbreviation towards Conference on Data System Language, and this was part of the development by Database Task Group DBTG, and this report was prepared and produced during 1971. And this was later implemented in very large variety of systems like IDMS, Image, Wax DBMS, etc. Some of the advantages of network model include: network model is able to model complex relationships. As associated with the networking concept in the field of computers, those are interlinked chains. Likewise, here every entity is related to another entity, every object is possible to correlate with the other objects. So, network model is able to model complex relationships and represents semantics of add or delete on the relations. This can even handle most situations for modeling using record types and relationship types. Language is navigational. Uses constructs like find, find member, find owner, find next, within set, get, etc. Programmers can do optimal navigation through this particular database. Some of the major disadvantages that this network model will go through is navigational and procedural nature of processing. Database contains a complex array of pointers that the thread through a set of records, and this has got a very little scope for automated query optimization. In order for, at later point in time we will read about what this optimization, query optimization would mean, but optimization is generally to reduce the time cost, but in order to maintain the quality of the entire product. But this network model reduces the complete scope towards development of optimized query. The next model is hierarchical data model. This was implemented in a joint effort by IBM and North American Rockwell around 1965. This happened sometime during network data model construction, resulted in the information management system. As we have suggested with the relational model where it was called network model where it was called CODASIL, Conference on Data System Language, part of DBTG group. Likewise, this hierarchical model is resultant of information management systems family of systems. The most popular model is the hierarchical model, where this stands with the hierarchy of a top down approach. The other system of this model is system 2K, which is a part of SAS Inc.'s production. Some of the advantages of this hierarchical model include: hierarchical model is simple to construct and operate on, and it corresponds to a number of natural hierarchically organized domains. For example, assemblies in manufacturing, personal organization in companies from the CEO to the developers and the low level authorities. The languages that are used here is very simple and uses constructs like get, get unique, get next with the parent, etc. So, when it is being constructed as a tree, so there is obvious relationship of a parent and the siblings or the parent and the child. So, anything that is to be got sometimes requires the parent details also. Some of the major disadvantages particular to this hierarchical model includes navigational and procedural nature of processing, database and limited query optimization. History of data models. To continue with the same history, we have one more data model which is called object relational data model, and this is more trending for nowadays because we have started slowly shifting down from hierarchical network and other models towards object orientation concepts. So, we are more towards object oriented model nowadays. So, started with Informix Universal Server and exemplified in the latest versions of Oracle 10i, and further on DB2 and SQL Server. So, now we will introduce some of the key words that are required to basically understand the entire system of database. Initially, we will define what a database schema would mean. Database schema is nothing but the description of a database that includes descriptions of a database structure and the constraints that should hold on the database. As we have said, schema is nothing but giving a clear representation of the entire structure of the database. So, this structure gives you a clear indication on the three tiers which we were talking about during our data model discussion, starting from the conceptual model, physical model and the implementation model. Likewise, all these schema would give you a clear representation of how a value or an entity would appear when it is at the external level, how it would appear at the conceptual level and at the physical level. So, to represent this, we will draw a schema diagram. So, this is a diagrammatic display of a database schema. And to define on the schema construct, a component of a schema or an object within the schema, like we can say it as a student, course. So, these all become a schema construct. About to define the schema construct, this student will include, in turn include student ID, student first name, student last name, date of birth and other details. Likewise, when I start defining another schema construct called course, every course have got course ID, course name and the session in which it is to be offered. So, those can be defined further on talking about schema constructs. The last key term that we are about to introduce is database instance. The actual data stored in the database at a particular moment in time. This is also called the state of a database. To talk more about the database states, the actual data in the database at a particular instant is the database state, which consists of a set of instances of each schema construct. Anything that we define as a schema construct relating to a set of instances on that particular time will actually be a database state. So, defining a database consists of specifying a schema to the database management system. We then have a database in an empty state where there has been no data. So, when the data is first loaded, the database is in its initial state. So, we have to define the schema constructs from then on. Subsequently, for every update creates another state. So, every record from then on, if it has been included or every instance been included, then it becomes an update and it moves from one state to the other state. So, the DBMS must guarantee that each such state is a valid state that satisfies schema's specifications. The schema is the intention, while the database states is the extension of the schema. So, any schema that we are primarily defining will be an intention, and any database state that follows this particular definition of a schema will be an extension of this. So, how do we compare ourselves with the database schema and the database state? To start with, what we have seen is a database state, which refers to the content of a database at a moment in time. And when is the actual state of initial state of a database state? Refers to the database when it is loaded. The valid state is a state that satisfies the structure and constraints of the database. So, anything that is coming under the structure and the constraints of a database, as we have initially defined, which obeys to the structure and the constraints, that is part of a valid schema, which later on became the schema of a database. So, this has got a distinction. The database schema changes very infrequently. So, the database state changes every time the database is updated. So, the schema is also called an intention, whereas the state is called an extension. So, this is how we differentiate ourselves between a schema and state. To give you a simple representation of a schema, we have considered a university database which has got different events, different entities like classroom, section, student, course, department, time slot, takes, instructor and advisor. So, this is a simple representation of an entity relationship diagram which we will be taking up in later sessions, but this gives us a clear structure of how database are connected. So, now that we have got different entities like student, department, instructor, advisor, course and other stuffs. So, how these are interlinked is the representation that we gain from a schematic representation. So, to look at the basic functions of database management system for the discussions that we had so long, the database management system is primarily focused on storage, retrieval and update and user accessible catalog. Later part of the database, after complete storage, retrieval and update, this can take up transaction support also. While at the part of transaction support, it can even carry out with concurrency control where multiple events can happen at the same time, and in case of multiple happenings there will be a lot of failure. So, in that particular sense we may have to recover those services, and for multiple access we may have to provide an authorization of a service, and further it has to support for data communication, and as part of the authorization we may have to check for the validity of this particular data towards that particular entity, and it has to carry out all its activities independently. So, services to promote data independence, and it has got many utility based services. So, as we have said, one of the functionality of a database management system is to maintain system catalog. We will try to understand what the system catalog generally means. The system catalog is generally a repository of information which is called as metadata. Metadata is defined as a data about a particular data. Say for example, if I define a table, this table has got, this table is just a data, and the metadata component of this particular table is the laminated sheet, the wood that is required, the keys that are around the table and the objects that are placed on the table would become the data about a data component that becomes the metadata component of the catalog. So, one of the fundamental components of DBMS is the storage. So, it typically stores names, types and sizes of the different data items. Not only that, it includes the constraints on the data and the name of authorized users. It also looks after data items accessible by a user and the type of access that we have to provide for those users. Now, we will look at the architecture that we are about to build for a database management system, but before that we will see how multiple users use this database management system architectures. So, this multi-user database management system architecture is being explained with three different structures. One is on a teleprocessing system, the second one is on a file server system, and the last one is about a client server method. If you look at a teleprocessing system, this is how it will be represented, where I have got a mainframe computer and all the other terminals are tried connecting to this mainframe computer. So, this becomes a traditional architecture where multiple machines are getting connected to itself with a mainframe computer. So, there is a single mainframe with a number of terminals attached to it, and this trend is now towards downsizing, where it cannot happen. It is primarily because the load of the mainframe cannot withhold with the capacity of the other terminals. So, for this downfall, or because of this particular disadvantage, we have shifted to a file server architecture system, where we have started collecting all the terminals, connecting all the terminals through a local area network, and here we represent the same mainframe server as a file server, and all the terminals are referred to as workstations here. So, several workstations are connected to the mainframe computer or a file server through a local area network, and every workstation sends a request for data and receives an acknowledgement or a file which is to be returned to that particular terminal, and this file server is in turn connected to a database. So, a file server is connected to several workstations across a network. Database particularly resides, or database specifically resides only on the file server. DBMS and its applications runs on each workstation. So, the workstation, the specific purpose of a workstation is to run basically the application at different terminals. So, the major disadvantages towards working on this particular file server architecture are: there will be a significant network traffic when requesting the same file server, and copy of database management system on each workstation has to be maintained for running its individual application. So, for these reasons we tried shifting to another architecture called traditional two-tier client server architecture, where instead of workstation these machines are named as clients, and through the same local area network connectivity these terminals are connected to a server which has the capability to manage by itself. So, there is a client which is working at tier 1, which manages the user interface and runs different applications. There is a server which holds a database and the database management system. So, the advantages of this particular system include wider access to existing databases, and it gives improved performance, reduction in communication cost, and increased level of consistency. So, any transaction that happens does not apply on the network traffic, instead it gives you a complete picture of consistency. So, this is a traditional two-tier client server system where client resides in the first tier and this database resides in the second tier. The major tasks that are associated with the clients include user interface, main business and data processing logic, whereas the task for the server includes validation and database access. So, this is a two-tiered architecture, but looking at the same two-tiered architecture in a different perspective of a client server, which is of a three-tiered format, where the client side presented two problems preventing true scalability. So, when we are referring to the more quantum of job happening at the client's end, we call it as a fat client. Fat client requiring considerable resource on client's computer to run effectively. So, significant client side administration overhead takes place. So, by 1995, 3 layers were proposed, each potentially running on different platforms. So, major advantage working towards this kind of a three-tiered client server architecture includes: here we have used a concept of thin client instead of a fat client, where the responsibility of the client is to basically run the application, not to entirely store on the database. So, thin client requires less expensive hardware, application maintenance is centralized, easier to modify or replace one tier without affecting others. So, this has a separating business logic from database functions, and this makes it easier to implement load balancing concept, maps quite naturally to the web environment. So, this is the representation of a three-tiered architecture, where the first tier is to represent the client, the second tier to represent the application server, and the third tier to represent the database server. So, the major tasks of the client includes user interface, application takes up the job of a business logic and data processing logic, and database server takes up the job of data validation and database access. So, now you could differentiate how we can differentiate between a two-tiered client server system and a three-tiered client server system. Now, the responsibility of the client is pretty less when compared to a two-tiered architecture of a client server system. Now that we have introduced another server which is called an application server, which is purely to consider on the aspects of two logics, business logic and data processing logic. So, as far as this three-tiered client server system is concerned, program that controls data transfer between clients and server in order to provide a consistent environment, particularly on a online transaction processing system, is referred to a three-tiered client server system. So, this three-tiered client server system with the online transaction processing will work like this. There will be several service calls from the individual client side which acts as tier 1, and this service calls in turn will be mapped to a TPM, transaction processing monitor, and it is being split as services which are to be requested from the database servers. So, this application server takes in the responsibility of converting the actual request from the client, taking up this service calls to the transaction processing monitor, splits that into different service calls and loads it to the appropriate database servers. So, the proposed three-tier schema of a client server system has basic characteristics of program data independence, and it basically supports multiple views of data. So, with this as an intention, people worked with ANSI Spark, have created a three-tiered architecture of a database management system which had internal schema, conceptual schema and external schema in it, and from these external schema, whatever that has been stored and the external schema will be viewable to the external world and the users might access from the external world. So, whatever that is represented initially will be updated to the external view, then it will be logically converted to the conceptual view and then physically mapped to the internal. This defines clearly the database schema at three levels: internal schema, conceptual schema and external schema. Internal schema at the internal level to describe the physical storage structures and access paths. It typically uses the physical data model, whereas the conceptual schema describes structure and constraints of the whole database for a community of users, uses a conceptual or an implementation data model, whereas the external level describes the various user views, usually uses the same data model as a conceptual model. For today's session, we have looked at data model, the different categories of data model which included relational model, hierarchical model, network model and object relational model, teleprocessing systems, file server architecture, client server architecture, and finally we have looked at the database system architecture which was defined by ANSI Spark. Thank you.